This is Professor Thad Stoner. Today we're going to do pull-up and pull-down resistors. Now, a lot of electronics hackers know the term pull-up or pull-down resistor, but a lot of times people don't know why you actually need them. So today we're going to start from scratch, and I'm going to show you why these pull-up and pull-down resistors are so important, and we're going to progress from that to actually using the concept for actually doing some sensing using a photoresistor. Okay, let's start with a simple voltage divider. So suppose I have some input voltage, VCC, and we'll make it, 5 volts for convenience. Might as well be concrete about this. And so I have my two resistors in series going to ground, and ground, as we know, is 0 volts. So we know that we have voltage drop across these two resistors. We also know that according to the formula, if I measure the voltage here to here, in other words, the voltage drop just across R2, it should be equal to the formula VCC times R2 over R1 plus R2. Now, in this case, let's make these resistors 10k ohm apiece, so 10,000 ohms. So in that case, well, doing the substitution, we get the obvious result of 2.5 volts. Okay, and we know that from our earlier lecture on voltage dividers. Now, let's put a voltmeter in there. Now, we said that having a voltmeter can actually change a circuit. Well, let's take a look at what happens in this particular circuit. So I'm going to put my voltmeter, I'm going to measure my use my voltmeter and measure across here. We know the voltmeter actually has an internal resistance of, say, 1 mega ohm. So now, instead of having R1 and R2, we basically have this whole thing here is going to be two parallel resistors. We'll do this as, say, the resistance of the voltmeter. And so the total, as we know from our previous lecture on resistors, is going to be 1 over R2 plus 1 over our voltmeter. Well, in this case, that's going to be 1 over 10,000 ohms plus 1 over 1 million ohms. Or, if I remember correctly, I've done this calculation earlier, this is approximately 9,903 ohms. Now, you can figure this out precisely on your calculator if you like. So now let's see how that changes the formula. So adding the voltmeter, actually measuring this voltage here, actually change what I'm measuring. Let's go back here now and change our formula to show what we actually are getting. So we're going to replace R2 with RT, the actual value. And so we end up with 5 volts times 9,903 ohms over 10,000 ohms plus 9,903 ohms, which is, let's see here, well, approximately still 2.5 volts. Because basically, when I look at this, 9,900 over 19,900 is still basically 10 over 20. So without even doing the calculation, I know it's still approximately 2.5 volts. So here I said we could have to worry about this, but obviously not a problem with this circuit. When does it become a problem? Well, let's redo the circuit, except now this time, let's do it as, I'll draw a right-hand circuit here so it's easy to see. I got my 5 volts up here, and now I'm going to do 1 mega ohm here, 1 mega ohm here, so my R1 equals 1 mega ohm, my R2 equals 1 mega ohm, and now my voltmeter with its resistance is now very much comparable to the R2 resistance. Well, that means our total resistance for this bottom part here is, again, the same formula. In this case we have 1 million. Alright, I lost zeros here. And so in this case, RT is going to be 500,000 ohms. Well, that may be problems because when I look at my formula again, with RT substituted in. Now remember, because these two resistors are the same size, I should get 2.5 volts here. But in this case, I'll get or 5 volts over 3, which is approximately equal to 1.67 volts. Well, that is not approximately equal to 2.5 volts. So here, putting that mega ohm multimeter in parallel with my circuit to measure the voltage drop really affected the circuit a lot. Now, why does this matter for pull-up and pull-down resistors? Well, let me take a look at, say, a PIC microcontroller. And we're going to look at its inputs, and we're going to do some of the same calculations with it based on what we just calculated.